Namaste, my friend, and welcome back to JEE Mathematics with Typical Monk. This is class 10, and today we open a new chapter, Inverse Trigonometry. Here is something worth sitting with for a moment. Sine, cosine, and tangent are machines that take an angle and hand you back a ratio. Today, we build the machine that runs backward, give it the ratio, and it hands you back the angle. But there is a catch, because sine repeats itself forever. So its reverse machine cannot simply exist unless we choose one narrow strip of angles to live in, the principal value branch. One idea at a time. Take a slow breath. Let us begin. So what will you carry home from today's class? First, the definitions and the principal value branches of sine inverse, cosine inverse, and tangent inverse. Second, the domains and ranges, the exact numbers every principal branch is allowed to touch. Third, properties, the complementary pairs, and the tangent inverse sum formula, correction term included. Fourth, identities, simplifying an expression like sine of cosine inverse x with nothing but a right triangle. And fifth, the JEE drills, a worked problem, a match, and a short answer round. Ready? One idea at a time. Let us start with the raw idea. An inverse trig function undoes the trig machine, feed it a ratio, and it hands back the angle whose sine, or cosine, or tangent produced that ratio. But sine repeats forever, so many angles share the same ratio, and a function must give exactly one output. David remembers this rule from the very first class that only a bijection has an inverse, so we restrict sine to a single rising branch. That one chosen branch has a name, the principal value branch, and it is the range every inverse trig function is forced to live inside. And a warning worth repeating, sine inverse x is never 1 over sine x. Sine inverse x is an angle, 1 over sine x is cosecant x, a completely different ratio. Now look at these three graphs, because together they turn the principal value branch into a picture. First, sine inverse x. Its domain is the closed interval from -1 to 1. And its principal range is the closed interval from -π/2 to π/2, a strictly rising curve, shaded band and all. Second, cosine inverse x. Same domain, -1 to 1, but its principal range shifts to the closed interval from 0 to π, and the curve now falls instead of rising. Third, tangent inverse x. Its domain is every real number, but its principal range is the open interval from -π/2 to π/2. The curve flattens toward two horizontal lines it can approach but never touch. Lisa's way of remembering all three. The shaded band is not a suggestion. It is the only place the output is allowed to live. Choose the wrong branch, and the answer is simply wrong. Now, the properties that JEE leans on again and again. First, the complementary pairs. Sine inverse x plus cosine inverse x equals π/2. Tangent inverse x plus cotangent inverse x equals π/2. And secant inverse x plus cosecant inverse x equals π/2. Each for every x where both sides are defined. Second, the odd ones. Sine inverse of -x equals negative sine inverse x. And tangent inverse of -x equals negative tangent inverse x. But cosine inverse breaks that pattern. Cosine inverse of -x equals π minus cosine inverse x. Third, the sum formula. Tangent inverse x plus tangent inverse y equals tangent inverse of x plus y over 1 minus xy, but only while x times y is less than 1. The moment x times y crosses past 1, the formula needs a correction of plus or minus pi. John treats these three properties like a toolbox, complementary pairs, odd behavior, and the guarded sum formula, because JEE builds entire questions out of just these three lines. Time to solve one carefully. The monk's way. Find the value of sine inverse of sine of 3π/4. Step 1. Write down what is given. We must evaluate sine inverse of sine of 3π/4, and it is tempting to cancel them and answer 3π/4 immediately. Step 2. Check the principal branch first. Sine inverse only cancels keenly with sine when the angle already sits inside -π/2 to π/2. and 3 pi by 4 does not sit there, so we cannot cancel yet. Step 3. Rewrite the inside using a supplementary angle. Sine of pi minus theta equals sine of theta. So sine of 3 by 4 equals sine of pi by 4. Step 4. Apply the cancellation now. Pi by 4 does sit inside negative pi by 2 to pi by 2, so sine inverse of sine of pi by 4 simply equals pi by 4. Step 5. The answer. Sine inverse of sine of 3 pi by 4 equals pi by 4, not 3 pi by 4. That gap is exactly the principal value chap G loves to set. Now watch. A single right triangle unlock a whole family of identities. First, let theta equal cosine inverse x. Then cosine of theta equals x. So draw a right triangle with hypotenuse 1 and the side next to theta equal to x. Second, Pythagoras hands us the missing side. The side opposite theta is the square root of 1 minus x squared. Read straight off the triangle. Sine of cosine inverse equals the square root of 1 minus x squared. Third, the same triangle gives tangent of cosine inverse x, the square root of 1 minus x squared divided by x. And fourth, the complementary identity returns sine inverse x plus cosine inverse x equals pi by 2. And the same pairing holds for tangent inverse with cotangent inverse and secant inverse with cosecant inverse. Now sit up straight. 5 lines G asks year after year. 1. Know the principal ranges called sine inverse and tangent inverse live in negative pi by 2 to pi by 2. Cosine inverse and cotangent inverse live in 0 to pi. 2. The tangent inverse sum formula needs its correction of plus or minus pi. The moment x times y is greater than 1, same sign x and y is the warning sign. 3. Expressions like sine of cosine inverse x or tangent of sine inverse x fall in seconds once you drop a right triangle and read off the missing side. 4. For a composed inverse like sine inverse of 2x, check the domain first. The entire argument, 2x, must still land inside negative 1 to 1 before anything else matters. 5. Sine inverse of sine of x equals x only when x already lives inside negative pi by 2 to pi by 2. Outside that branch, always reduce the angle first. Exactly like our worked example. Let us drill the G way. I read a claim. You decide true or false, and if it is false, find exactly where the reasoning breaks. First claim, sine inverse x equals 1 over sine x. Check the definition. Sine inverse x is an angle. The angle whose sine is x, while 1 over sine x is cosecant x, a ratio, not an angle. This is false. An inverse function and a reciprocal are two completely different ideas. Second claim, sine inverse of sine of 2 pi by 3 equals 2 pi by 3. Check the branch. 2 pi by 3 sits outside negative pi by 2 to pi by 2, so we cannot cancel directly. Rewrite it as sine of pi by 3, instead using the same supplementary angle trick. This is false. The correct value is pi by 3. Third claim, tangent inverse of 1 plus tangent inverse of 1 equals pi by 2. Check it directly without the sum formula because 1 times 1 equals 1 and the formula's denominator would collapse to 0. Adding the two angles directly, pi by 4 plus pi by 4 does equal pi by 2. This one is true, but only because we added directly and skipped the broken formula. A quick match now. Say each range aloud before the reveal. Sine inverse x maps to the closed interval from negative pi by 2 to pi by 2. Cosine inverse x maps to the closed interval from 0 to pi. Tangent inverse x maps to the open interval from negative pi by 2 to pi by 2. And cotangent inverse x maps to the open interval from 0 to pi. If all 4 ranges came to you before the reveal, the principal branches are becoming yours. Here is a favorite G format. I read some statements, you silently count how many are correct. Statement 1. Sine inverse x is defined only for x between negative 1 and 1. Hold your verdict. Statement 2. The range of cosine inverse x is the open interval negative pi by 2 to pi by 2. Think before you answer. Statement 3. Tangent inverse x is defined for every real number x. So, how many are correct? Two statements, the first and the third. Sine inverse truly needs its input between -1 and 1, and tangent inverse truly accepts every real number. But the second one falls because that open range belongs to tangent inverse, not cosine inverse. Cosine inverse actually ranges over 0 to pi. Two correct statements, 1 and 3. Now let me save you some marks. Two myths that trap thousands of students every year. Myth 1. Sine inverse x means 1 over sine x. It looks so natural, the little -1 up top just seems like an exponent. But here is the truth, that -1 is inverse function notation, not an exponent. Sine inverse x is the angle whose sine is x, while 1 over sine x is cosecant x, an entirely different quantity. Myth 2. Sine inverse of sine of x always simplifies straight back to x. The truth, that cancellation only works when x already sits inside the principal branch, -pi by 2 to pi by 2. Step outside that branch, and you must reduce the angle first, exactly like our worked example taught us. Time to test yourself, rapid fire. Here is the rule. I ask, you answer in your head before the reveal. No pen, no paper, just the ideas you built today. Question 1. What is the principal value of sine inverse of 1/2? Pi by 6. Question 2. What is the domain of cosine inverse x? -1 to 1. Question 3. What is the range of tangent inverse x? The open interval -pi by 2 to pi by 2. Question 4. Sine inverse x plus cosine inverse x equals what? Pi by 2. And question 5. Does sine inverse of sine of 3 pi 4 equal 3 pi by 4? No, it equals pi by 4, exactly as we found in our worked example. If you caught all 5, you have truly understood today's class. Let us gather the whole class in one slow breath. Inverse trig functions undo sine, cosine, and tangent, but only inside one restricted principal value branch, so the output stays a single angle. Sine inverse and cosine inverse live on the domain -1 to 1. Sine inverse ranges over -pi by 2 to pi by 2, cosine inverse ranges over 0 to pi, and tangent inverse accepts every real number in the open range -pi by 2 to pi by 2. The complementary pairs always sum to pi by 2, sine inverse with cosine inverse, tangent inverse with cotangent inverse, secant inverse with cosecant inverse. The tangent inverse sum formula needs a correction of plus or minus pi the moment x times y passes 1. A right triangle collapses expressions like sine of cosine inverse x in seconds, and sine inverse of sine of x equals x only inside the principal branch. And next class, we step into the properties of triangles, the sine rule, the cosine rule, the projection formula, and the area of a triangle. Do not miss it. And so, my friend, we have tamed the reverse machine. Sine, cosine, and tangent will keep returning throughout calculus, and now you know exactly how to run them backward, one careful branch at a time. Sarah, David, Lisa, and John have all walked through this exact confusion. Cancel too fast, and the principal branch punishes you. Be patient with yourself. Tonight, revise the 3 ranges once, slowly, out loud. One idea at a time, you will crack G of this, I am certain. If this class brought you clarity, subscribe to the channel so the next one finds you. Until then, keep going. I will see you at the properties of triangles.